Here's my class.
What would happen if no one showed up?
Then I would take a nap. Yeah. Oh, it's right here. Why is that not? Oh, no, Ben emailed me earlier saying that he wasn't going to be here for the Zoom. That's right. Yeah, but McKinley would have to know that go on Zoom and figure it all out. And I don't know if he's been on Teams yet or not. Have you guys?
I'm more dead, but I haven't done it.
All right. Well, since we're talking about it, I'll show it to you.
Because Miss McCall is always just tells you to.
Right. Oh, this isn't doing it.
Upload things on there.
Why don't you see this? Oh, because I got mine. That's true. I do, though. Well, I got to think all the other teachers must do the same thing, because how else would they? Really? Well, how does he get the stuff to his kids then?
I guess he just emails.
Oh. All right.
Oh, yeah, he uses Google.
So do I, but I just put it in Teams. So yours may not look exactly like this. Right? Yours may not show up in tiles. Sometimes it's on the right side, but you'll see all, 7 of your classes type thing. So when you click on geometry, I mean, there's all these announcements, but I don't have much control. Anytime I post something, it shows up there. So there's just like tons and tons and tons. But if you go to right here under assignments, they're in numerical order and whatnot. We're going to have another student in class, but she's not going to physically. She's a 9th grader in the other 9th grade class. She's really good at math, and she just asked, hey, can I take geometry as well as Algebra 1? And I said, yeah, sure, why not? But she's going to take it online. She's not going to ever show up or anything like that, but you might see her name or something like that. So anyway, this is what you're going to see, and this is why you see lesson 1.1, because I posted for her to catch up and watch and whatnot. So you don't have to do this. I also got to explain this to Ben, because he's going to, no, I made this only for her, so Ben would not see this. Anyway, you will see, oh, by the way, here's the test. I will not click on that. But you'll see all of your assignments of when they're due. So when you click on your assignment like 3.5, and when you actually click on it, we click under student view, here's kind of, it just tells you what your homework was. And then down here, it'll show a link to the class. Now, I actually have to upload it and then post the link, so I don't get this done I get it done early in the evening. But so every day that you show up for class, then it's just a Google form, and it's got, I only need your name and stuff just so there's a record that you actually did the class. But then, it's just literally the stuff that this should have been yesterday's class. Or no, a couple days ago. Blah, blah, blah.
You just add up all the interior angles. Look at what you just wrote there. Oh, yeah.
They see McKinley's alive.
It doesn't matter what shape. If the answer is always.
All right. So anyway, and then it asks you how many questions. This is just more so for me, just to say, if you said, hey, I'm missing everything every single day, then I know there's a problem or something like that. But anyway, and then you hit submit, and then I have a record of it type thing. On the Google form, on the Teams itself for you, you will have to, you don't see it here, but right here where it says student work, there's a submit button. So you just take a picture of your homework. I'll show you one that Ben did. Let's see, how do I do that? Or Madison, one of the two. So here's Madison. She already did her homework, and you can see that she attached her homework to it. There's just a picture of her homework type thing. So, and look, she did the whole table, and there's answers there. I had to print it out to actually see it. I can't zoom in. But anyway, that's what it looks like for me. And probably this year at some point, we're going to have a snow day, and we're going to say it's a e-learning day. So you'll have to go on here to get your homework. And it will always be when you click assignments, it will be the very, very, very last thing is the very last assignment. So these say schedule because they're not showing up on yours, but on yours, If you scroll to the very bottom, the very last one would be the most recent one type thing. So it's pretty self-explanatory. And as long as you can log on, it's not that big of a deal. There's also a chat feature. So if you wanted to, send Ben, hey, I won't be able to attend today's Zoom meeting. I'll watch the video as soon as I can, and I'll sit at home, blah, 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 right? So you can ask questions, and, oh, there was this test. So I hand back the test and all that jazz as well, too. So anyway. Okay, today's class. Ben's going to be embarrassed now since I showed his test. And I'm recording this. Oh, wait, I didn't share the screen, so he couldn't see it. He was seeing me talking the whole time. Questions on the review sheet? All right. We got one thing left, and that's the last section. And it is literally a 10-minute class. It's a 10-minute class. So, and I will print it off more than I need. All right, so review tomorrow. It's not like we normally do. I will literally show you a copy of the test. What? Yes, please. I forgot you weren't here. Right, but you were here. So I already gave you credit for it. And then Mr. Brubaker is going to give you the test because I'll be in a meeting. So here's your homework tonight. Some of these are going to be very, 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 very simple, and some of them are, you got to do a little bit of thinking. Ready? I said 10 minutes. You can time me. All right. Let's see. So this is going to be something called inductive reasoning. The word itself isn't very, I don't know, revealing of what this actually is. Certainly, it's something about logic, reasoning, that sort of thing. Very short class. So the last 3 chapters, we've shown things to be true. We've shown things to be true because we have proven them, right? All of our postulates, theorems, and corollaries. We've proven the theorems and the corollaries. The postulates were just things. Oh, somebody's here. Is that you, Ben? Somebody.
McKinley.
McKinley, how are you feeling, buddy?
Okay.
All right. Thanks for showing up. Good deal. Did you do your homework?
Yes.
Okay, you don't need to turn it in. I'll take your word for it.
All right.
Okay, so this is a minor fine point, right? So for all postulates, theorems, and corollaries, if you meet the if part, like if you are the if part, because we've proven this stuff, then the then is we accept it, it must be true, right? Because we've proven these things. So it's not like it's sort of kind of true, it's always true. If, pun intended, you meet the if part. So for instance, if you are vertical angles, what? If you are vertical angles, then you are congruent. There's not like sometimes, it's always. So it's a fine point about this, and that's the difference between what we've done in the past and what we're doing today, inductive reasoning. Okay, so if 2 angles are vertical, then they must be congruent, right? Not sort of, kind of, but always. What we've been doing, you can write this down in box 1. This doesn't have to go in your book of truth. What we've been doing is something called deductive reasoning, right? Not inductive, which is what this class is about. We've been doing something called deductive reasoning. And I always think of it like a detective, right? So a detective's investigating a crime and they want to convict a criminal. They can't like present crummy evidence. They got to produce hard, unassailable, convincing evidence. And so what deductive reasoning is, it's a logical method of thinking about things, but it's where the conclusions, they're based on accepted statements. And that's the theorems, postulates, and corollaries, if you want to frame this in a mathematical sense. The conclusions must be true right? If you meet the hypothesis, if you are a vertical angle, then you must be congruent. So all of that type of reasoning, in fact, most, 99.9, except for the class we're doing today, is deductive reasoning. We will do some other inductive reasoning if you take a higher level math course in geometry, but for the most part, almost everything we do in the book is deductive reasoning. Okay. An interesting side note is deductive reasoning, except for the one that I mentioned, is it's rarely used in real life. I mean, most people don't use deductive reasoning. We use what we'll introduce here in a second is inductive reasoning. For instance, every time that McKinley walks into the classroom, I sneeze, right? So the next time McKinley walks in the classroom, guess what happens? I would think that I'm going to sneeze, right? Is it guaranteed I'm going to sneeze? Yeah, because that's not deductive reasoning. Deductive reasoning, it must happen, right? I might be sneezing and it might be a coincidence type thing. But the deductive reasoning is rarely used. We generally, as human beings, we make those connections of coincidence, of I don't know, we say common sense, but it's not very common. It's not sensible in the sense of it's not based upon logic or reasoning. I usually do this thing where I slap someone's hand and I progressively slap it harder. And eventually I get to the point where I go to slap it, and guess what happens? They move their hand. So I make the point of, if the rule is I'm going to slap your hand if you raise it type thing, and I progressively, at some point you're like, hey, I've had enough, and they pull their hand away type thing. I'm not going to hit your hands. That type of reasoning is not deductive reasoning. Deductive reasoning would say every single time you raise your hand, I'm going to smack it, right? You're using something called what we're about to talk about right now. Here's another example. So, it's kind of the same thing. So, and this is from the book. So, after picking marigolds for the first time, this lady begins to sneeze. The next 4 times she picks marigolds, she sneezes. A typical human being would put 2 and 2 together, so to speak, and they would immediately think that maybe they're allergic to the flowers. I mean, is that true? Could it be true? It could be true, but it also could be true that maybe she's allergic to the grass growing underneath the marigolds, or the fertilizer that they use, or something about the physical location of the things growing there she might be allergic to. This is the type of reasoning that most human beings do. So this is not deductive reasoning. Deductive reasoning would say absolutely positively, if you get in front of marigolds, you're going to sneeze. In sports, if you throw a curveball, and every time you throw a curveball, the guy hits a home run, eventually you're going to do what? I'm not going to throw a curveball, right? But, deductive reasoning would say every time you throw a curveball, the guy is going to hit a home run. We know if we think about it in more general terms, well, that clearly that doesn't happen. But yet people make decisions in life based upon recurring patterns. And that's the kind of thing we're going to talk about today, because this type of reasoning is certainly not deductive. Deductive reasoning says they must hit a home run. So what we're talking about is something called inductive reasoning. So inductive reasoning are conclusions based upon past observations. You see a pattern, and you make a decision or a conclusion based upon those observations. Conclusions are probably true. In professional baseball, if a batter hits a curveball a bunch of times, he doesn't get pitched a curveball anymore because the pitcher knows that he's probably going to hit a home run. It's not a guarantee, but they see that pattern and they make their reaction to that pattern. They are using something called inductive reasoning. He might hit a home run, or he's more likely to hit a home run. The conclusion is probably true that he'll hit a home run. So that's called inductive reasoning. This is generally what humans use for reasoning. Hey, am I going to go outside, or is it going to rain? Well, last time I went out, it rained on me, so I'm going to bring an umbrella this time, right? It's not guaranteed to rain simply because you have an umbrella or you don't have an umbrella, right? There's probability involved there. So today we're going to be doing inductive reasoning. So an example, in order to steal a precious gem, a diamond, you actually got to touch the object and steal it, right? So that means you got to touch it, even exclude the fact that you can have gloves on. So the cops find your fingerprints on a diamond that's been stolen. Are you guilty?
Might be, right? You could have touched it, right? You might have stolen it. But equally likely or equally possibility is that maybe you were, touching because the person in the museum allowed you to touch the diamond or something like that. And that's why your fingerprints are on there. Once again, this is what's called inductive reasoning. Yeah, we find your fingerprints on a stolen diamond, and the police are going to come and talk to you, right? Why are your fingerprints there? That doesn't mean you stole the diamond. So this is an example of why the police would want to talk to you, but it doesn't convict you. You don't get convicted of the crime simply because your fingerprints are on the murder weapon or whatever. Certainly, they're going to talk to you if your fingerprints are on the murder weapon. All right, here's another one. The cops see you stealing it. I mean, they literally see you on a video stealing the diamond. It's a true video. It hasn't been messed. Are you guilty? 100%. You're guilty, right? 100%. This is not inductive reasoning. This is if they see a video that hasn't been doctored, right, and you are stealing something, you absolutely stole it. This is called deductive reasoning. So the two words and this is the only hard part about the homework is they're going to ask you, they're going to give you a scenario and say, is it inductive or deductive reasoning? You just have to make sure you look at your notes. Which is the one that's probably true? That's inductive. Which is the one that must be true? That's deductive reasoning. So if there's no possibility, that, okay, I mean, and don't think about this thing too much. Oh, I was play acting, stealing the diamond. That's why I'm on the video. They don't really mean that. They're the more logical thing that would happen. So how do we use inductive reasoning in math class? Well, it's pattern recognition, basically. We're trying to recognize a pattern. Allie, you see the pattern? So what's the next number? No, it's 14. What's inductive reasoning say? Right, but what's inductive reasoning say? Most likely 10, but it could be 14, right? So just make sure you're aware of that one minor dip. Yeah, we're going to put 10 as an answer here for homework, but just remember, we're not saying it is 10, but most likely it's 10. For homework, I think they have you write the next two numbers. Right? So it's not that challenging, right? You just figure out what's, and you've probably seen tests like this. Hey, pick the next two numbers, that sort of thing. All right, so this is the end of the class right here. So we're going to do these four, we're going to call it a day. Hey, McKinley, can you do the top left one? What are the next, what's the next number?
Eight.
Did you say what?
28.
28. Well, let's see. To go from 11 to 15, that's most likely plus 4. To go from 15 to 19, that's
Plus 4.
okay. 19 to 23, that's
Plus 4.
you're not guaranteed that the next one's plus 4, but most likely. So McKinley, one more time. What's the answer?
27.
Thank you. Anna? Well, what's happening to get to 4 to 6?
Add 2.
It looks like add 2. Could you get to 4 to 6 through multiplication? There's not a number I can multiply 4 by to get to 6. Well, 4 times 1.5, right? That would be 6. So what I mean is that you got to make sure that you think this through. So yes, the easiest thing to do is just simply say, hey, how do I get from 4? Oh, I'm increasing. I must be adding 2. But also remember, it could be add, subtract, multiply, or divide. Right? So how do you get from 6 to 9?
Plus 3.
How do you get from 9 to 11?
Plus 2.
How do you get from 11 to 14?
Plus 3.
Do you see a pattern? So what do you predict the next number to be?
16.
Not guaranteed, but we would say 16. What's the next number after 16?
19.
Yeah, okay. Now, they will include positive and negative numbers that are either added or subtracted or multiplied or divided tonight for homework. So you just got to be ready for that. Generally, how do you go from a large number to a small number? How do you go from a large number to a small number?
Subtract.
Or
Divide.
it's either subtraction or division go from large to small. You go from small to large, it's either addition or multiplication. Okay, so
2. Is most likely.
oh, you already done the math. Okay, well, how did you figure that out?
7 down to 4 is minus 3.
Agreed.
plus 2,
Okay.
and then minus 3.
Okay, so we can combine those operations. So just make sure you can see a pattern. So therefore, the last answer is most likely it's 2. Okay. McKinley, you want the last one? It's the hardest one. How do we go from 3 to 6?
3.
Yeah, it looks like plus 3. How do we go from 6 to 18?
13.
Plus 12. Then 18 is, we can see there's something, I mean, like a pattern is not emerging. Right? If this was maybe, I don't know, plus 2, plus 22, plus 222, maybe that's a pattern. But I don't really see a pattern plus 3, plus 12, plus really big number. So maybe it's not addition. Maybe it's, how else do we get bigger?
Multiplication.
How do we go from 3 to 6?
Times 2.
How do we go from 6 to 18?
Times 2.
How do we go from 6 to 18?
Times 2. I mean, not 2. 3.
How do we go from 18 to 72? What's your guess?
4.
Therefore, what we have to do with 72 to get to the next number?
5.
Okay, and that's kind of the idea. And it's 360 to multiply by 5. Yes, McKinley?
Yes. Yeah, I got it.
So the 2 things they're going to ask you tonight for homework are, they're just going to give you a string of numbers and ask you what are the next 2 numbers. Some of them are, challenging. Some are not very challenging. And then they're going to give you sort of written form, a scenario. You just have to identify whether it's inductive or deductive. Inductive means that, well, it could happen, but it's not. It doesn't have to be that way. Deductive means it has to be. Why is the person guilty of the crime? Right? If there's incontrovertible evidence, it can't be like hearsay. Well, I think I saw a person that looked kind of sort of like that person. That's inductive reasoning. For instance, you spent time in prison on 4 different occasions for robbing a bank. A bank next to you, to your house, gets robbed. Well, the police are probably going to come and talk to you and say, where have you been? Why? They're using inductive reasoning. Who's most likely to rob a bank? Bank robbers. Doesn't mean that you robbed the bank, but it means maybe you robbed the bank. So just keep that in the back of your mind when you're trying to figure out whether it's inductive. Some of those are a little bit more challenging, inductive and deductive. That's it. So some of the examples would be like this. So Ramon noticed that spaghetti has been on the school menu for the past 5 Wednesdays. He decides that the school always serves spaghetti on Wednesday. Inductive or deductive reasoning?
Inductive.
That's inductive reasoning. Right? There you go. Kai figures out that if you add the lengths of a triangle, you find the perimeter. He notices on several equilateral triangles that you just simply need to take one side and multiply by 3. What's he using? Why deductive?
Because they're all equilateral.
All equilateral sides are all the same, so therefore it would be 3 times the side length. So he's using deductive reasoning. So this is kind of what it looks like. Right? All right, that's it. Thanks for showing up, McKinley. Did you find this on Teams, or how did you find this link?
Teams.
Nice. Good job figuring that out. You feeling any better?
No.
No? Well, make sure you stay hydrated and get some sleep.
Okay.
All right. I'll catch you later, McKinley.
All right.
Oh, there's McKinley. I see a face. Why don't you guys see the face? Oh, because I got this on. And there he is. He's alive. See you later.